So this is our project, and we're gonna let a yo-yo unravel, and we want to find the rotational kinetic energy and the translational kinetic energy. For this problem, we're going to be trying to find kinetic energy rotational. Okay, so we've chosen to work with an energy lens because we have the yo-yo at a height of 1.2 meters, so it'll have potential energy at the top. So when we let it unravel from 1.2 meters, we can look at how the rotational kinetic energy and translational kinetic energy compare. We can see that potential energy is equal to mass times gravity times height, and with our variables over here, we can see that height is 1.2 meters, mass is 0.07 kilograms. After doing the calculations, we get a potential energy of 0.84 joules.
Okay, so we had the height of the yo-yo at 1.2 meters, and then we got from the video and we saw how long the yo-yo took to fall, and that was 0.8 seconds. So to get the speed, we took the distance and divided by the time and got 1.5 meters per second. So then we used that in the equation for translational kinetic energy, which is 1/2 mv squared, and plugged it in, and we got 0.08 joules.
Oh, like Pete does, you know?
Okay, pause, stop.
So now we're going to assess the answer, and when you're looking at what the potential energy turns into, it has to do with the radius, and since the string's attached at a very small radius, every time the yo-yo does one rotation, it goes down a smaller amount of string than if it was attached by a big radius, because then when it does one rotation, it would go down further, which means that the translational energy is less than the rotational energy.
So it also makes sense why the kinetic energy rotational is a lot bigger, because since the yo-yo is small and light and has a short radius, its inertia, if you look at the inertia equation with such a small radius and such a small mass, that means the overall inertia would be very low. And inertia it's rotational resistant to change. So with a super small inertia, it means that as it falls, it'll start spinning and rotating way quicker than it would if it was larger. So that makes sense why more of the energy is being converted, because it's a lot easier to convert that energy into rotation rather than just falling straight down translationally.